We all agree that this rose is red, right? I mean, I call it red, you call it red, but how do I know that you're actually seeing red? I mean, maybe you see this as I see blue, but you just learned to call that color red. I suspect we've all had this conversation at some point in our lives, generally late at night, potentially augmented by some mind-altering substance or another. We wouldn't be the first. The inverted spectrum thought experiment appears in writings by John Locke, no less, meaning this gets into some heady philosophical waters, the nature of consciousness and qualia, the subjectivity of experience, and physicalism. If only some brilliant scientists could scan our brains while we look at various colors and actually test what we are perceiving. Yeah, they finally did. We are in a brand new era of neuroscience, thanks to machine learning and artificial intelligence. We've never had that much difficulty generating data from human brains. We can put people in MRIs and functional MRIs, strap EEG leads to their scalps, all sorts of things. But the problem has always been interpretation of that data. There's just too much of it. So we were limited to picking out big, obvious things. This EEG suggests the person is sleepy or asleep. This fMRI suggests the person is activating their motor cortex. AI tools have started to change this because you can feed a big complex data stream into an algorithm along with some very specific labels. This is a human looking at a square. This is a human looking at a circle. And the algorithm can start to learn from that data in ways that we haven't been able to. There have been some startling feats of mind reading that have resulted from this type of research. One study trained an AI model on subjects in an fMRI scanner while they listened to podcasts and other audio. Then they had the individuals think various thoughts and were able to reconstruct them using only data from the fMRI scanner. Crazy, right? But there was a catch. Language is so complex that a model trained on one person only works to read the thoughts of that one person. Applying a model trained on me to your brain leads to gibberish. And that forces us to think about the nature of subjective experience. Is it possible that my whole inner world is different from your whole inner world? That my experience of reality is wholly different from yours? That what I see as red, you see as blue, even if we call them the same thing? Enter this study appearing in the Journal of Neuroscience. The title is a mouthful, as you can see here, but there is a tantalizing word in the title that caught my eye as I was reading through papers this week. Shared. The experience of color might be shared across human brains. Do we finally have an answer to the inverted spectrum question? Here's how the study worked. 15 participants with normal color vision were put in an fMRI scanner. The first step was to map their visual cortex. You may remember from anatomy or neuroscience courses that the brain has a map of the human body called a homunculus built into it. It's a little funky looking since areas of the body that require a lot of processing power, like the hands, are bigger than other parts. But basically the hands are next to the arms, are next to the shoulders, and so forth. It's similar for your visual field. There's a map of the back of your eyeball on the back of your brain. The researchers mapped the visual cortex by showing the participants black and white grids to see what parts of the brain lit up. Now, all of us are pretty similar here, but there are person-to-person differences. Once those differences were mapped, the researchers could sort of line up the brains computationally to remove that variation from future analyses. Then they introduced new signals. The new signals? Colors. Participants were shown rings of red, green, or yellow colors while they were sitting in the scanner. The researchers then measured what part of the visual cortex was getting stimulated. They then started with the easy question. If you've mapped the color signaling within a person, can you tell what color they are seeing in a blinded test? In other words, they've determined that I see red in this specific area of my visual cortex. Can they predict if I am seeing red only looking at my personal brain activation pattern? And the answer, I think unsurprisingly at this point, is yes. At least they could do way better than chance. Remember, there were 3 possible colors, so by chance alone, researchers would be right 33% of the time. Depending on the brain area examined, they were right significantly more often than that, up to 57% of the time in one specific part of the visual cortex. And that's all well and good, but it doesn't really answer the inverted spectrum question. To get at that, you need to see whether you can predict the color someone is seeing without using their prior data as a guide. And that's just what they did. Using a model trained on all the participants except the person of interest, they made predictions about what color the person of interest was seeing. Again, chance here would be 33% accuracy. Surprisingly, fascinatingly, the researchers found they could, in fact, predict what color someone was seeing, at least to a degree statistically better than chance. This suggests that color perception works very similarly in all of our brains, which opens the door to all sorts of questions. First, why? Why should we all see red in the same small part of our visual cortex? This study can't tell us, of course. The authors suspect there may be evolutionary pressures that pushed us all collectively towards this setup, or perhaps there's some emergent properties of the connected brain that just make this area the right place for color detection. As our tools to probe these signals get better, we'll learn more. But then the big question, we all agree this rose is red, and now we know that when we look at this rose, we all activate a very similar part of our brain to confirm that it is red. So, is that it? Do we all see red the same? And the answer is maybe. We are actually running up against the edge of the philosophical concept of physicalism. Is subjective experience, the redness of red, purely defined by the synapses that activate when exposed to a red stimulus? If our mental state is purely determined by the physical state of our brain, then the answer is yes. That's the end of the story. We all have similar synapses. We all probably see red the same way. I know the predictions weren't perfect, but remember, they weren't perfect when the model was tested on the same brain it was trained on, implying it's the resolution of our measurements, not inherent brain differences, that drive the lack of perfect prediction. But there will always be doubt here because none of us can truly be inside the brain of another. Non-physicalists would say, great, the synapses firing are the same. That says nothing about the personal experiences of those synapses firing. Qualia cannot be determined instrumentally. For me, that last explanation feels anti-scientific. I'm not saying it's untrue, just that if the problem can't actually be tested experimentally, it loses meaning to me. It's fun, for sure. I enjoy imagining an experience of the world wholly different from my own, but if I can never know whether such a world exists in another's mind, then I probably shouldn't spend too much of my neural processing on the idea. Thanks for taking a trip back to 3 a.m. in my college dorm with me. Maybe next time we'll just do a bunch of trolley problems. For Medscape, I'm Perry Wilson.